Electric charge can not only exist on an object, but it can also move through an object. However, materials differ vastly in their abilities to allow electric charge to move or to be conducted through them. To help illustrate such differences in conductivity, consider the conduction of heat through a bar of material whose ends are maintained at different temperatures. As section 13.2 discusses, metals conduct heat readily and therefore are known as thermal conductors. On the other hand, substances that conduct heat poorly are referred to as thermal insulators. A situation analogous to the conduction of heat arises when a metal bar is placed between two charged objects. Electrons are conducted through the bar from the negatively charged object toward the positively charged object. Substances that readily conduct electric charge are called electrical conductors. Although there are exceptions, good thermal conductors are generally good electrical conductors. In conductors, electrons are free to move. Metals such as copper, silver, and salt water are good electrical conductors. In fact, copper is used in electrical wiring. Materials that conduct electric charge poorly are known as electrical insulators. In insulators, the electrons are not free to move. In many cases, thermal insulators are also electrical insulators. Common electrical insulators are rubber, glass, wood, and many plastics. Insulators, such as the rubber or plastic that coats electrical wiring, prevent electric charge from going where it is not wanted. The difference between electrical conductors and insulators is related to atomic structure. As electrons orbit the nucleus, those in the outer orbits experience a weaker force of attraction to the nucleus than do those in the inner orbits. Consequently, the outermost electrons, also called valence electrons, can be dislodged more easily than the inner ones, called core electrons. In a good conductor, some valence electrons become detached from a parent atom and wander more or less freely through the material, belonging to no one atom in particular. The exact number of electrons detached from each atom depends on the nature of the material, but is usually between 1 and 3. When one end of a conducting bar is placed in contact with a negatively charged object, and the other end in contact with a positively charged object, as we have seen, the free electrons are able to move readily away from the negative end toward the positive end. The ready movement of electrons is the hallmark of a good conductor. In an insulator, the situation is different, for there are very few electrons free to move throughout the material. Virtually every electron remains bound to its parent atom. Without the free electrons, there is very little flow of charge when the material is placed between two oppositely charged bodies, so the material is an electrical insulator. In summary, conductors can conduct electricity because electrons are free to move as free electrons. Some examples of good conductors are copper, gold, iron, and salt water. Insulators do not conduct electricity or conduct it poorly because the electrons are bound to the atoms and are not free to move. Some examples of good insulators include plastics, rubber, glass, and wood. Finally, in general, good thermal conductors are good electrical conductors.